Hello. So today I will do one lecture of BM607. Now this will be completely online today because the institute is on holiday. So probably next few lectures I'll try to record and upload on the Google Classroom. So today I will be discussing about arterial blood gas analysis. Arterial blood gas analysis. This is something which will be a little bit essential to understand ventilators, because blood gas analysis, which affects the acidity and basicity of the body, or the blood supply in the body, can be affected by how the ventilators function. So that's why I typically teach a little bit of ABG, which this is also called as ABG, before going into ventilators. And it's also pretty interesting to understand how the lungs and kidneys are actually related. So arterial blood gas analysis, or ABG, is a measure. Like, this is a measure of acidity or alkalinity of your arterial circulation. Okay, so this is a measure of acidity and basicity of arterial circulation. So there are a couple of important parameters associated with this. First one is, maybe I'll have to move to another sheet, because this sheet has already been used for something else. Okay, so arterial blood gas analysis. So first, there are a couple of important parameters which are associated with arterial blood gas analysis. Uh, first one is pH, which is acidity or alkalinity. It indicates acidity or alkalinity. So this, I hope everyone is already aware of what pH is. It is the concentration of hydrogen, and this is a hydrogen concentration in a particular solution. So the normal pH of body is between normal pH of the body is between 7.35 to 7.45. Okay, so this is normal. So as you know, the pH scale varies between 0 and 14, 7 being absolutely neutral. So if body's pH is between 7.35 and 7.45, that means the blood is typically little bit acidic. Okay. Then second parameter which is important in this is partial pressure of carbon dioxide, PaCO2. Okay. This is partial pressure of carbon dioxide. This is its normal value is between 35 to 45 mmHg, which is normal value. It is controlled by lungs. This is controlled by lungs. Okay, and more PaCO2 means blood is more acidic. More PaCO2 means blood is more acidic. Okay, then there is another important parameter, which is HCO3 minus, okay, or we call it bicarbonate, bicarbonate ions, bicarbonate ion concentration. Bicarbonate concentration. Bicarbonate concentration, the normal value are between 22 to 26 millimolars per liter. Okay, is the normal range of bicarbonate. There is also the partial pressure of oxygen, which is typically not used in determining the. It is not typically used in arterial blood gas analysis because it is something which is automatically derived once you know the PaCO2. So this is the normal value of partial pressure of oxygen is between 80 to 100 mmHg. Okay, but in normal arterial blood gas analysis, only these three parameters are the important ones. Okay. Now another thing which I forgot to mention is HCO3 minus. HCO3 minus is normal is between 20 and 26 millimolars per liter. So this is produced everywhere in body and regulated in kidney. So we can write like this, that CO2 is produced everywhere in body and is regulated in regulated through the lungs. Okay, while HCO3 minus is produced everywhere in the body but is regulated through the kidneys. Regulated through the kidneys. Okay. So the formula is basically when carbon dioxide which is inhaled through carbon dioxide which is produced in the body. So the formula for it is when it mixes with water in the body, H2O plus CO2, then it dissociates to form it forms this carbonic acid H2CO3, which can then dissociate to form HCO3 minus plus H plus. Okay. Now CO2 is done. It has a respiratory regulation. Like if you breathe harder, you will remove a lot more you can remove carbon dioxide from body, while kidney can remove HCO3 minus. So this has a regulation through kidney regulation. Okay. So if H plus goes up, okay. So if PaCO2 goes up, you can see this relationship. If PaCO2 goes up, H plus also goes up. So H plus is directly related to PaCO2. So H plus will go up if carbon dioxide goes up. So this also means that carbon dioxide is responsible for the acidity of the blood. So more carbon dioxide in the body, the more acidity of the blood. Okay, and the acidity of the blood can be reduced by removing by regulating the acidity of the blood can be regulated either by removing carbon dioxide. Like acidity can be reduced either by removing carbon dioxide or by increasing HCO3 minus or stopping the removal of HCO3 minus. Okay. So kidney pumps out some HCO3 minus to make the overall blood mildly acidic. Okay. So overall, this equation, if nothing is expelled out of body, as per this equation, the body still remains neutral, but kidney removes some of the HCO3 minus, which makes the overall blood a little acidic. So that's why the blood's pH remains between 7.35 and 7.45. Okay. If pH is if pH goes above 7.45, we call it alkalosis. Okay, if pH greater than 7.45, this is called as alkalosis. And if pH goes below 7.35, we call it acidosis. Okay, so alkalosis can lead to this can lead to muscle weakness. This can lead to muscle weakness, muscle cramps, and dizziness. While acidosis can lead to headache, nausea, diarrhea, vomiting, vomiting, seizures, and protein denaturation. Protein denaturation. Okay. So the formula for calculating pH on basis of the concentration of HCO3 minus and PaCO2 is given by this formula. pH is equal to 6.1 plus log of base 20 HCO3 minus concentration divided by PaCO2 into 0.03. Okay, so this is the formula for calculating pH if you know the values of concentration of HCO3 minus and partial pressure of carbon dioxide. To test it, you can do an example. uh, for example, let's look at the normal value. Normal value of HCO3 minus is normal value of HCO3 minus, if we go, is between 28, 22 and 26. So let's take it 24. And normal value of PaCO2 is 35 and 45. Let's take it 40. Okay, so let's take 24 and 40 and put it here. So example, let's put, so for that, for normal CO3 minus equal to 40 and PaCO2 is equal to sorry, HCO3 minus equal to 24 and PaCO2 is equal to 40. The values would be pH is equal to 6.1 plus log base 20 multiplied by 24 divided by 40 into 0.03, that is equal to you can calculate, it will come out to be 7.4, which is the most normal which is the normal pH number, because pH has to be between 7.35 and 7.45 for normal values, and it comes out to 7.4. Okay, so both respiratory and renal problems can lead to acidosis or alkalosis. Okay, so if you have a problem with either your lungs or anywhere in the respiratory system, or a problem in the kidney, both can lead to change in the pH value of the blood. Okay, so there are now depending on what led to, so both lungs and kidneys can lead to acidosis or alkalosis. So depending on where exactly your acidosis or alkalosis has arrived from, it can be a metabolic acidosis, metabolic alkalosis, or it can be respiratory acidosis and respiratory alkalosis. Okay, so typically the metabolic acidosis or alkalosis takes days to affect. Okay, so HCO3 minus is regulated by kidneys and takes days to take effect. Okay, while PaCO2 is regulated through lungs and can change pH within minutes. pH of blood within minutes. Okay. So in metabolic acidosis, so if there is a so there can be four types, as I told: metabolic acidosis. In this, what happens is metabolic acidosis means it is happening in kidney. So kidney can only regulate HCO3 minus. HCO3 minus is something which is the basic part. Okay, so it's kind of the alkaline part. So it's the alkaline part of that chemical reaction which we discussed earlier here. Okay, so kidney can take down the HCO3 minus, and the acidity of the blood will increase, or it can stop removing HCO3 minus, and then the blood will become alkaline. Will start becoming more alkaline. So there can be metabolic acidosis in which HCO3 minus basically what will happen? It will go down, and there can be metabolic alkalosis in which we can have HCO3 minus going up. Okay, and there can be also respiratory acidosis in which PaCO2, because respiratory acidosis means it is happening in the lungs. So lungs can increase the acidity by increasing PaCO2, or they can reduce the acidity or produce alkalosis, respiratory alkalosis, by reducing PaCO2. Okay, so let's take some examples to understand how will you diagnose whether it's a respiratory acidosis, respiratory alkalosis, metabolic acidosis, or metabolic alkalosis. Okay, so first thing is so you will measure these three parameters to identify to do this blood gas analysis. One is pH, PaCO2, and HCO3 minus. So for example, let's take a table of values. Suppose this is pH, this is PaCO2, this is HCO3 minus, and this is your diagnosis. Okay, so pH is 7.5. Say pH is 7.5, 7.25. pH is a 7.25. So clearly, you can, by looking at this value, you can say whether it is a alkalosis or acidosis. Okay. So as this is less than 7.35, it is more towards the acidic value. Okay. Because so it is definitely acidosis, because it is less than 7. This number is less than 7.35. So this is towards more towards the acidic side, because from 0 to 7 pH is considered acidic, and from 7 to above pH, 7 to 14 is considered the basic region, like above the neutral region. Now now here 7.35 to 7.45 is our normal region. Anything below that is acidic, and anything above 7.45 is basic or alkalosis. So here it is acidosis. Now PaO2 value is given as 50, and HCO3 minus is given as a 24. Now based on this, HCO3 minus, the normal range of HCO3 minus, as I have discussed earlier, is between 22 and 26. Okay, so this is between 22 and 26, so this is a normal range, while PaCO2 should be between 35 and 45. It is more than 45. So, and more PaCO2 means more acidic, so that means it is a respiratory acidosis. Okay, so this is a respiratory acidosis. Okay, so this is the diagnosis which we can do on basis of these numbers. Now suppose the number is given as 7.56 is the pH. If the 7.56, that means it's more than 7.45, so this is definitely alkalosis. And the PaCO2 is given as 28, and HCO3 minus is given as 22. Okay, the normal range of PaCO2 should be between 35 and 45. So this is less than 35. Okay, so that means this is causing alkalosis because it has went below the normal value. Because PaCO2, if it goes up, it produces acidosis. If it goes down, it produces alkalosis. It is now below the normal value. So that is definitely respiratory alkalosis. But let's also check the HCO3 minus. Its normal range should be between 22 and 26, and it is 22, so it's almost normal range. So this is basically respiratory alkalosis. Okay, now let's take another example. Suppose the pH value is given to be 7.25. Okay, again this is acidosis, and this is given as 37 PaCO2 and HCO3 minus is given as 21. So here PaCO2 is should be between 35 and 45, so this is normal, and this one is should be between 22 and 26. This is less than 22, which is basically this will cause, if HCO3 minus goes down, it produces acidosis. If it goes up, it produces alkalosis. So this is producing a metabolic. So this is metabolic acidosis because it is happening due to HCO3 minus, and PaCO2 is normal. Similarly, after this, one more example: 7.56, 40, and 35. So this is 7.56. That means this is alkalosis, as it is more than 7.45, and 35. So this 40. Okay. 35 to 45 is the normal range. So this is normal. This one should be between 22 and 26, but this is higher than 26. So this is metabolic alkalosis. Okay, so this is the way you analyze from these values of pH, PaCO2, and HCO3 minus whether something is respiratory acidosis, respiratory alkalosis, or metabolic alkalosis, or metabolic acidosis. There can also be, what happens is, once the body enters into acidosis through one organ, the other organ can come in and try to change its value. For example, if HCO3 becomes imbalanced, PaCO2 also starts to diverge in a range such that the overall pH comes back. Overall pH tries to come back in the normal range. Okay, for example, so this is called as compensation. So there can be partial compensation or there can be full compensation. For example, let's take an example of partial compensation. So in case of partial compensation, what happens is body tries to accommodate the non-performance of the renal system with the by changing the performance of the respiratory system, or the non-performance of the respiratory system by changing the performance of the renal system. So this is how. So what happens is pH still remains mildly abnormal, but there is a underlying compensation. Okay, for example, I'll give you example: pH, PaCO2, and SCO3 minus. So pH is 7.33. So pH should be between 7.3 and 7.45. Now pH is 7.33, means it is mildly acidic. Okay, mildly acidic. And the PaCO2 you have checked. You check PaCO2 and it comes out to 48, and HCO3 minus is 95. Okay, so PaCO2 normal value should be between 35 and 45. So that means PaCO2 is elevated. Okay, and HCO3 minus normally should be between 22 and 26. Okay, while this is also elevated. So what has happened is PaCO2 has become elevated due to non-performance of the respiratory acidosis, because of which, to compensate this, HCO3 minus has started going up to compensate for this value. So this is compensated respiratory acidosis. Okay, so this is compensated respiratory acidosis. Similarly, there can be cases where So this is 7.5, 7.34 to 7.5 is normal. So this is alkalosis. Mild alkalosis can be seen, and the PaCO2 came out to be 65 and this is 50. So both of them are in abnormal range. Okay, so HCO3 minus should be between 22 and 26. It is elevated, and PaCO2 minus is also elevated. It is much above the 45 range. Okay, so you have to see which value is closer to the normal range in some sense. So 35 to 40, it should be HCO3 minus should be 22 to 26. So what happened is what might have happened here is that HCO3 minus went up because of non-performance of the renal system, or problem with the renal system. To compensate for it, so if HCO3 minus started going up, the blood started becoming more alkaline. To restore the blood back into its acidic towards the acidic side, the the body started moving PaCO2, like PaCO2 up by changing the breathing patterns in the lungs. Okay, and that led to increase in the 65 increase of the PaCO2. That means there is a lot more carbon dioxide which is getting retained in the blood. Okay? So this is compensated. This is compensated metabolic acidosis. Okay, so PaO2 is actually related to PaO2 is related to your SpO2. So you can actually detect this in the pulse oximeter. So if your overall oxygen concentration is going down, your overall carbon dioxide concentration in the blood is going up. That means the overall concentration of carbon dioxide going up in the blood, and that can be captured through also captured non-invasively through pulse oximeter. Okay, but to actually find out the whether it is respiratory alkalosis or actual, to get one of these actual diagnostics, you need these three parameters. Okay, so only a pulse oximeter will not be sufficient, but that can definitely give you some indication of where the acidity of the blood is going. There can also be full compensation. This is partial compensation. There may also be full compensation. So full compensation where pH, this means the pH is restored to the normal through compensation. Okay, but PaCO2 and HCO3 minus continue to be abnormal. So your pH is between 7.35 and 7.45, but PaCO2 and HCO3 minus are both abnormal. In this case, we say that there is an underlying problem in the underlying system problem in the respiratory um, and the renal system, but there has been a full compensation. So the pH is not showing any abnormality, but there is underlying abnormality. Okay, so example can be say 7.5, PaCO2 49, and SCO3 minus of 30. Okay, so if you put this in this formula here, you'll see SCO3 minus and PaCO2 input, and you will find the pH will be 7.5. 49 and 30 you put, and you get 7.5. And this is something which will give you a normal pH. So this is a normal pH, but both the PaCO2 and HCO3 minus are abnormal. Okay? In this case, the patient may come in with a respiratory problem. So in this case, how do you diagnose that what the patient actually what problem the patient actually has, whether it is a respiratory problem or it is a renal problem? That you can identify by looking at whether the patient has come in with a respiratory problem or they have come with a respiratory problems. If they have come in with a respiratory problem, then they have respiratory acidosis. But if they come in with diarrhea or vomiting, that means they are losing acid. Okay, diarrhea and vomiting are the way of losing acid from the body. So that means they have metabolic so they have which means they have a metabolic alkalosis. Okay, So this is all I wanted to discuss for arterial blood gas analysis. So after this, we'll take up the ventilators. Hopefully, I will come back to you with another lecture. Thank you.